Hi everybody. We've got today's lesson, operation with complex numbers. We've just been introduced to complex numbers. Remember that I is equal to the square root of -1. Whoa. And that I squared is equal to -1. And this is going to come into play a lot today. Just remember that. And that the standard form is A plus BI form. So we're going to take complex numbers and add them together, subtract. We'll do a little multiplying, and we're going to do a little dividing and talk about how that's done today. Now, it's very similar to your variables, so when you're doing this, you can add your real parts, your 7 and your 5, and you can add your imaginary parts, your 3i and -4i, and then that's 12, and then 3 and -4 is -1. So I just write that as 12 minus I. So you're just combining like terms. With addition and subtraction, it's as simple as combining like terms. So that's all I'm going to do here on this next one. 3 minus 5 is -2. 4i minus -3i, that is 4i plus 3i. So that is 7i. I don't know if I'm skipping too much. I feel like I am. So I'm going to write 3 plus 4i, and then I'm going to take out the parentheses here. Minus 5, and a negative is plus 3i. And then when I put everything together, that's 3 minus 5 there. Put those two together, and then 4i plus 3i there. Okay, multiplying, we're going to distribute, we're going to FOIL. So here's the distributive property. -5 times 3 is -15. -5 times -2i is positive 10i. Okay, so everything you learned with variables still applies here. And FOILing is the same way. So if we go first, 2 times 3 is 6. Outside, 2 times 3i is 6i. Inside, -4 times 3 is -12i. And last, -4 times 3i is -12i squared. And if I combine like terms, I got 6, and then I'm going to make minus 6i, that's -6i, and then -12i squared, but I squared is not going to be acceptable. Anytime there's an I squared, we're going to substitute it -1 with it. So I've got 6 minus 6i, and -12 times -1 is positive 12. The 6 and 12 we'll put together and make that 18 minus 6i. That's our final answer. 2 minus 4i times 3 plus 3i, that's equal to 18 minus 6i. So there's multiplication. Now division it's kind of like rationalizing the denominator in things we did earlier, but we need to use the complex conjugate. J comes next. Conjugate. Complex conjugate. The complex conjugate of A plus BI is A minus BI. So what I'm going to do is, I don't want a complex number in the denominator. So it's kind of like dividing. It's 2 plus I divided by 2 minus I. We're going to multiply top and bottom by the conjugate of 2 minus I, which is 2 plus I. And we don't want to change the actual value. So rather than dividing, we're multiplying by 1, but it's the conjugate, the complex conjugate of the denominator. So we've got to take 2 plus I times 2 plus I, and that's over 2 minus I times 2 plus I. I'm going to do the denominator first because I want to show you why this works. So if I FOIL this out, 2 times 2 is 4. Outside is plus 2i. inside is negative 2i, and last is negative I squared. Okay, I'll keep working my way down here. The positive 2i and negative 2i cancel out. That's 4 minus, and then I squared, don't forget I squared is negative 1. So that's 4 minus negative 1. So this denominator is 5. 2 minus I times 2 plus I is 5. So that's what we're just trying to do, is make the denominator completely real. Now I'm going to go ahead and multiply, do the foiling on the top. That's 4 plus 2i plus 2i, and then plus I squared. And then that numerator, 4, and those like terms make 4i there. And then I squared is negative 1, right? And then 4 minus 1 is 3. And then plus 4i. Now, that looks pretty nice, but if I want to do standard form, which is what I want you to do, I'm going to write 3/5 plus 4/5 I. Here's my real part is 3/5, my imaginary part is 4/5. Okay.